Am I audible?
Yes, sir.
Okay. So the plan is today we'll start with AQ questions, right? Then I don't know if you are how much you have done and all. So if you have doubt on the PQ, that also can be addressed. And then if time permits, we'll see some programming questions also, right? So initially, let us start with the AQ. So let me share my screen. Is it visible? Anyone can answer? Is it visible?
Yes, yes.
Okay.
Yes, sir.
So these are very simple questions. So can we go little fast? Like first one, what is the syntax for declare a parameter type? So we basically use a triangular bracket, right? We use a triangular bracket like this. Yeah. Hello?
Yeah. Template, right?
Yeah, template we call it in C++, but here
Yeah.
we'll say it's a parameter type for the generic. Yeah.
Okay. Generic.
Yeah. So which of the following type parameters are valid? Invalid. So why these two are invalid? Anyone?
Yeah, it should be a name, right?
Yeah,
Valid
we
name.
cannot use a symbol, but what about this one?
It's a reserved keyword.
This is a keyword, right? Whenever we'll go for serialization, we'll see this. So if you have a doubt, you can stop me. Otherwise, I'm thinking like everything is fine. I'm going to next. Which of the following type declarations are invalid based on type definition given below? So this is the type definition. So which are invalid? So it's saying these two are invalid. Why?
It can't be special. It
Those
can
are not objects. It should be primitive.
It should be a reference type. It should be a reference type. Like it should be a class, right? These are wrapper classes. So int is a primitive data type which you cannot use. But what you can use a corresponding class, which is a integer, which is a wrapper class. So class is a reference type. A primitive type is a value type. So primitive types cannot be used for this type parameter, right? It has to be a class or a reference type. So that's why it works over here, but doesn't work for int and float. Okay. So is it properly visible, my screen? These questions are. Do you want me to enlarge a bit?
Yeah, the 4 options are not coming.
No, options it's fine, but can you see the questions properly? That's the thing is.
Yeah. Whole question
Okay. So consider the program below, choose the correct options. So it is asking whether there is an error or it generates output. So quickly, can you scan through it? So look at here, the class is not generic type, right?
Yeah.
Function is a generic type. The function is a generic type. So instantiation of class is not generic, right? So it's fine. But whenever you're calling your class, function, the method, you're passing different types, right? So array 1 is of type integer, right? Array 1 is of type integer. So it goes into S. So S will be now instantiated with integer. And array 2 is an array of string. So T will be instantiated with string. So in this case, we'll get it as it prints the array S first. Array is having the integer, so it will print 10, 20, 30, 40, 50, right? It will print 10, 20, 30, 40, 50. And then it prints the array 2, it prints the array 2, which is the array of string. So it prints this IIT, then Madras, Java, programming, etc. Right? But in the next call, the array 2 becomes the first argument. Now array 2 is of type string. So S now take or instantiated to string, right? It is not integer now. And array 1 is the second argument, which is of type string. Array 1 is of type integer. So T will be instantiated to integer. So whenever I'll print the first array, that's the array of S type, it prints the string. So it will print IIT, then whatever the strings are there in my array, then it will print the integers. So do you have any problem? Is it clear?
Yes, sir.
Yeah, no problem.
Okay. Which of the following are the advantages of generic in Java? Right. So it's not about the encapsulation and abstraction. It's basically all about the type safety. So what happened? If I create a generic type using an object type, right? So if I take an object array, suppose it is a object A equal to new of object, suppose it's a 5, right? Now what may happen inside the position 0, you can have a 10. Inside 1, you can have a character. Again, inside A of 2, you can have a string. So the array will become a non-homogeneous, it becomes a non-homogeneous kind of array. So you can have a integer, you can have a character, you can have a string. Now you may ask, what is the problem if it is non-homogeneous? Now whenever you are creating a loop and going to read A of I and going to assign it to something, how do you know what is the data type of AI? That's the problem, right? You don't know. So how to
No,
cast it?
but I can take it through object, right?
Yeah, all are become now object type. All of this becomes object type, right? Now, if I have to cast it, how do I know? I have to cast it to int, I have to cast it to float, or I cast it to double. So that information is lost, right? So that's why it's not a type safe in that way. See, suppose I want to do an operation like I want to have a sum as a integer or some other variable you want to do of I. Now the thing will happen, for this one it may work fine, for this one it may work fine, but whenever it comes over here it may works in a different way because this type doesn't match, right? I'm just giving an example. So it's basically non-homogeneous kinds of collection, not basically safe, right? So that's why basically it's not a good way to use this object types, because once we have casted it to object type, we actually forget about what is the actual type of that particular object. So that is the problem. So that's why the first thing, the explicit casting is not required. So if I want to bring back this to again int, I need to do explicit casting. That is not required in case of generic, and it also provides a type safety because different data types supposed to works with different operators and they works for different operations, right? So if I lost the data type, how do I know which operator, which operations will be permitted on that particular object? That's the problem is. Choose the correct code block to bound the type variable T of class example where X is an interface. Where X is an interface. What is that?
Yeah, can you explain this topic a little more?
Yeah. See,
Because yeah, it is the interface and why it is extend.
if I say class example T, I'll say this is a unbounded type because T could be any data type, right? Which is a reference type, right? Which could be a reference type or a class type. Is it okay? But I
Yeah.
called it as a bounded.
It should
If
be
I
number
put a
type.
limit, simple way, if I say extends something S, that means for T, I'm putting a upper limit that T is something which is inheriting S. T is something which is inheriting S. If I say,
So,
yeah,
so
just 1
as
minute. Example, just 1 minute. T extends number. That means upper limit of T is a number. That means T could be any child class or the number, right? Any child class of the number, or it could be number. So it could be then integer, float, double, like this, or it could be a number. So now remember, this implements doesn't work for setting the upper bound. So it has to be either extends or a super. Super used for setting the lower bound. That means T should be a super class of X. T should be a super class of X, right? So X should be my child. X should be my child. So X is the lower bound. And if I'm saying X extend X, that means X is my upper bound. X is my upper bound. But this super normally used for the question mark, that wild type. Normally you won't see it using for a parameter types. Yeah. Yeah, somebody was telling something, right?
yes, sir. So yeah, we have written that T extend S, no, and
Yeah, yeah.
S is the type. So
It's just a
in,
syntax. We don't have this implement keyword for a parameter type.
okay, so there is a no meaning that it is the X is that interface or class.
No, no, it's just the upper limit or lower limit. So if you have a inheritance, this is inherited by this and inherited by this. So you can say for these objects, the upper limit is this and lower limit is this. So you can say if this is a T, this is U and this is V. So you can say T extends U or T is a super of V, like this.
T, if I write the T is called super of the V, that
V.
means V is inheriting T.
V is a, yeah, means T is a super class of V, right?
Okay, okay. So only the two concept is here, upper bound and lower bound.
Yeah,
So
only the upper bound and lower bound. Yeah.
okay,
So
so
it
this
could be an interface, it could be an abstract class, it could be a class. It does not matter.
okay, so this extend the completely different meaning, that there is a no meaning comparison with that in the class where we do extends and the implementation.
Can you repeat once?
In the class, whenever we create a class and we inherited inheritance do, then
Hmm.
we either do the extend or the implement. So
Yeah, yeah, yeah.
this extend is completely different than that. So there is no relation of this extend to there.
No, no, it's basically the same extents, because extend, if I say T extend X, that means T is a child class of X, right? The meaning is same, but we are not using two different terms, like different for implement, different for interface as a implement, and different for, we are
Okay,
just
because
checking out what is my parent, what is my child, that's all.
okay, okay. That means here there is a no multiple parent, multiple upper bound.
Yeah, it's
That,
there, it's
that
there. We can do it in a different way. I'll show you
okay.
that.
Multiple upper bound is also there.
Yeah, that's also there. That
Okay,
is
okay,
there. I'll show you. But
okay.
bit careful about the super. Hmm. So
Yeah.
normally for parameter type, you don't use it. We have to use it with a
So
wild type.
so we can write the super T super X as the same as the X extend T.
T extend X, X extend T. No, the meaning is not exactly same. Um, I'll suggest you go that wild card kind of that chapter properly. So rather
Okay.
than discussing it today, We'll take the topic on next because it's little bit conceptual. It's a bit difficult. So I think you will read twice, thrice that particular thing before we go for it. So that's why today, like we in the activity questions, I think we don't have that wildcard and all much. So we'll discuss it anyhow.
Okay.
Okay. So, but the concept is this: putting a upper bound and lower bound of your type. That's the concept. Is so. Okay. So next question. So this is similar, right?
If you can explain 6.
So T extends number. So it could be a number type or any child type of the number. So it could be, that's why an integer. So if I pass an integer, that will be accepted, right? That will be accepted. But if you give a integer over here, you cannot pass a single quoted a because you are passing a character, right? So in that case, it will give error. But if I typecast it to an integer, that means we are basically passing a 65, the ASCII of A. Is it clear? Since I have instantiated with an integer, I cannot pass a character, right? So that's why this A I have casted to a int, so that now it is permissible because now it becomes a 65, the ASCII value of capital A. So that will be passed. So this is instantiated now as an integer. So integer extends number. So this is correct. Now T is a int. So this is a 65. So X also becomes 65. Now whenever I call get, it basically prints a 65. So anyone, any doubt? Anything? Am I audible? Hello?
Yes, sir. Yes, sir, you are audible.
Yes, Arup, you are audible.
Okay. This one.
Yeah. Can you explain little detail here, sir?
With this one?
Yes.
Yeah. First, would you like to check out what is happening? Because it's quite simple. If you just read one statement, you can understand what is happening.
Only, yeah, that is the problem.
Yeah, what I told, that instantiation of a parameter type must be a class type or a reference type. So does that rule satisfy over here?
No, sir.
What about this? This is a primitive type. No, that is not accepted. So instead of that, if you pass a double, which is the wrapper class for a double primitive type,
Okay.
then it will work.
So if I change something and double, I convert in the number or integer. If I convert double to the integer and that in the function class repository, if I make it integer, then
Here
it will
you are
work.
saying you will make integer.
Yeah, double to convert integer. Yes.
If you just write integer over here, it will give an error, right? But if you write it as a int 5.5, then it is fine, because here you need to pass an integer then.
So if I write number,
if you write 5, no problem, because it's an integer. But if you just write 5.5, the data type will be double. But
no,
you have
so
mentioned here, if you write, if you just give a 5, no problem. If it is an integer, it will take it.
no, I'm keeping the 5.5 same, and that data type I'm putting the number or something.
Number.
We can't put the number there, the repository string comma number.
Yeah, you can give it string comma number. That's also possible. For that, this 5.5, I believe it will work. You have to check it once.
Okay.
It will work, I feel,
Okay.
because it is allowed. Yeah. You can just run the code and check it out once. Or maybe after discussion, I'll check out, and the time it will end up, I'll tell you. Okay, this one. Anyone want to say anything about like this number? If I give a number over here, will it work or not? I know it is work, but how do it behave? I have to check out. Anyone want to say if I write number over here and pass 5.5? I don't see anyone commenting. Okay.
Can you go back to the code?
Yeah. So it's basically if we write it here as a string and a number, and we pass ABC, this is fine. 5.5. This is.
It should work now.
Yeah, it should work, but how the output will come, that is.
Yeah, I mean
like
you mean the toString method, right? How will the
yeah. It will show 5.5 or it will do something, that is my doubt. It will work, I know also.
It will show 5.5, sir. I checked.
Yeah. Okay. Okay, this one. What will happen for this code? So the type instantiation happened to what? Character. So what you can push now? All character type. Right? Now what about this statement? What we're passing?
A string.
They're passing a string, right? So which supposed to give you a compiler error, which supposed to give a compiler error.
Yes.
So this is not the correct, because it is compiler error, but not for this reason, because we are having a unbounded type here. So there is no problem of instantiation. It will take care. It's not a runtime error also. The program doesn't print A also. So none of the above, because it's a compiler error. But the instantiation is with the character, but I'm trying to push a string. That is the problem. That is the error. Is it okay?
Can you explain the first statement a little more? What's the actually
this statement?
No, that in option first statement, and what will the suitable question for this statement?
Yeah.
Means what is the answer?
Program? Yeah, program gives the compile time error because type argument is not within the bounded type. So bounded type means whenever I have a t extends number, so t becomes a bounded type, means it has to be number of any child type of a number. So in that particular case, suppose I pass a boolean. So boolean is not inherited from number, or it is not a number. So this error will come in that particular case, that it is not within the bounded type, because the t is bounded within the upper limit of number. But boolean is not like that. So it is this error. Am I okay? Does it make sense?
Not fully clear, but one thing more, sir. Suppose what will be the modified option, so it will be correct, the option A.
Yeah, the correct option will be, the compile time error will be, so your string type, sorry, your repository type is now, it's a repository of character, right? So what is the push method? The push method template, push method instantiation happened like a character where getting, because T is now character. So if T is a character push, character where it becomes. Up to this, is it clear?
Yes.
Now what I am doing, a dot push and passing a string. So this is a string type, and here I'm expecting a character type, which doesn't match, right? So it will say string cannot be converted to character.
Okay.
Now tell me if it is really clear, because it is not a, yeah, if it is really clear, tell me. See, if I say instantiating with a character means T becomes a character. Up to this is okay, right?
Yes.
Now T is the parameter type of push. So it's character where we, after instantiation.
Yeah, there is a no add option in that character. Something.
No add option means it basically becomes a
Character, yes.
character where. But what you are passing? You're passing
Is
a
it
string type.
correct? The first of all thing is data will not match.
Yeah, that is what I'm saying. String cannot be converted to a character. That will be the error, right? I'm
Okay.
passing a string, you're expecting a character.
And
So
one
it's
more
not.
thing. Yeah, one more thing is I'm writing a dot push. That means I'm behaving a as the array type, no?
No, don't take it in a like data structure push and pop. It just name as a push and pop. It's basically a set function and it's basically a get
Okay,
function.
okay. Push
It is a
already.
single variable. Your mind is working in a stack way. That's the problem happening. So it's basically set function, which is assigning the var to the this var, and set is returning the var. It's just a single variable. Instead of get and set, we have a push and pop.
And okay, sir. So what will happen if in the line a dot push a is there? So I can change the data type of a dynamically there in the something character I can change there, no?
If
Okay.
the type of this is a character, it will be accepted. No problem.
Okay.
But you have to pass a character. That's only the thing. If you pass anything other than character, it will reject it.
It is clear now, sir.
Excuse me, sir.
Yeah, please.
Sir, I was not able to join meeting due to some reason. Can you quickly explain that declaration in the angular bracket? I gone through first two videos, but I was not able to understand that generic.
Okay.
If it is possible for you, please repeat.
No, for this one only I'm repeating it once.
Yes, sir, please.
Oh, it is taking so much time, so I'll just change the color. Okay, so this is a repository. Here is a generic type and T is the type parameter, right? So depends on instantiation, like how you create the object, it takes the type T. So whenever you say repository in the triangular bracket, it's a character, I say that T will be instantiated with a character. So that means what will be the type of var over here? It becomes a character var, right? What is the data type over here? It's a character var. So in case I do a dot push a single quoted a, so that means what? This a, which is a character, will be passed as a var, and this accept a character only because T is now character. Is it okay?
Yes, sir.
So the var will be assigned to this var, means this is now a single quoted a.
Yeah.
Now, whenever I call pop is like a get function which will return you back which type? T. What the T in this moment? It's character again.
Yes.
So it returns back your single quoted A. So you'll get the output as A. But in this particular case, we are passing a double quoted A.
Okay.
So that means we are passing a string, right?
Yes, sir.
But this function is instantiated as
Character.
var. So you're passing a string, but you're expecting over here a character.
Yeah.
So that's why it gives a compiler error that string cannot be converted to a character.
Okay. And so that repository type that we mentioned as a character, it can be anything, no?
It could be anything, but it should be a reference type or a class type. It cannot be a primitive type, just a int, double, float.
Okay. It should be non-primitive or the class or
non-primitive. So if you pass int, it will give an error, but if you use
integer.
Corresponding wrapper class, integer, it will take
Integer.
it.
Okay. Yes. Yes, sir. Thank you, sir.
Thank you. So, yeah. This one. I think it is understandable, right? If I say T extends vehicle, that means T should be any subclass of vehicle or it should be vehicle. Which of the following option is used to declare a wildcard?
Sir, one question here.
Yeah.
Can we go on the question once? Yeah. So one question is there's just a little outside of from this question related to that only subtype. So if a parent class is there and child class is there, so we can say the child is the subtype of the parent. Means child is extending the parent.
Yeah.
There is a two class. One is the parent, one is the child, and child is extending the parent. So I can say that child is a subtype of the parent. Okay, another way. So what is the inherit? So parent is inherit.
See, it's a, you can write T should be any subtype, the subclass or subtype, or it's a child, or it's inherits, all basically the same. So you can say T should be any subclass of vehicle, T should be any subtype of vehicle, T should be a child of vehicle, T should be any, or T inherits vehicle. So these are basically means the same, right?
Okay, but one of the lecture, the earlier lecture of the professor, he was telling about the stack Q and the DQ.
Yeah. So in the context of Java, basically implementation of subtyping and inheritance is in the same way. Is in the same way, right?
So okay, so in that case, it was looking the parent is inherit the child.
No. Subtyping doesn't mean a inheritance. So it's a different concept. It's basically concept means a superset subset concept. It's a, so if I have a set A,
okay, yes,
and set B, so I'll say B is a subtype of A. B is a subtype of A. So that's the concept. But in case of Java inheritance, basically that is the way we achieve the subtyping and the as well as the inheritance, because
who is the inherit to who in that case right now, sir?
Yeah, just I'm telling you, see, if you say T extends vehicle, so you need to understand what is there in vehicle must be there in T.
Correct.
And T should have more than that thing, like some other features also.
Yes.
So can I say T has a subset as a vehicle?
Yes.
So T is a subtype of vehicle?
1 second.
Sir, here if we are extending any class, then it should be extended by the subtype.
Yeah, that becomes in Java, in case of Java, but conceptually they're different. Yeah.
Yes, it is.
But
it
in
is
Java, the implementation of inheritance and subtyping happens simultaneously. That's the point. So we
Yeah.
are not separating the concepts here in Java.
And the reverse will not be true. We cannot extend T by vehicle, obviously, because we cannot extend a parent class by the child.
Yeah. Getting my point? Because a child, the parent is already a subset of a child, no? Conceptually. Because what parent will have, child obviously will have, child can have something extra along with that. Am I making it more confusing or clear? I don't know.
Can you take that one example, the same example of the queue and the
No, don't try to think in that way. So it's basically a theoretical concept, right? It's basically a theoretical concept.
I tried to correlate that, but the concept was coming
No,
there.
no. Whenever you are writing a Java code, as per the Java code, the parent-child relation is made or implemented in such a way, child will become a superset of the parent.
Child
But it
will
may
be,
not be true whenever you take a real-time scenario. That's the point is. So theoretically, we can differentiate between a subtyping and inheritance. But here, whenever we're extending, we're basically doing the both the things.
so in the exam, in the paper, if it will come, then I can confidently say that child is inherit parent and the child is the subtype of the parents.
If it is coming from a theoretical concept, we never say it's a child and parent kind of thing. We'll have a two different names and we'll try to explain in terms of features. Like
Okay,
this
so
class will have this feature, this class having this feature. So who is the subtype and who is inherited from whom? Because if I
yes,
go
sir.
for a
So
parent-child relationship, somehow I'm telling you it is Java specific, so it's basically the same thing. I'm telling you the answer rather. If I say who is child, who is parent, right?
yes, so whenever I say the child and parent, that means by default it is understood that
Yeah, in
child
case
is
of this implementation, Java implementation, yeah, it's happened
okay.
simultaneously. Yeah.
Okay.
Okay, which of the following are is used to declare wild card type? So it's basically this one. This very much theoretical. Consider the Java program given below.
Sir, can you please explain what is wildcard type briefly?
Wild class, I need to give an example. So let us see like any example is coming next, then I'll
Sir.
explain it, right?
Okay.
Otherwise, I need to check out a right example for it.
Okay, sir.
So this is basically the declaration of wild type. Wild type means you're not going to define the particular parameter type like a T or something else. So it's just a question mark, means it's a anything. It could be anything. So this is an example of generic constructor. So can you check out and tell me what will be the answer here? So it's not an answer, it's basically the correct option it is asking for. So correct option so that it will compile. So it's basically very easy to answer by seeing the number of arguments, right? How many arguments are there in the constructor?
2.
So how many you should pass?
2.
2, right? If you don't pass 2, it will give obviously the error. But if we do the first kind of call, what is S and what is T? The instantiation of S and instantiation of T?
Source and target array.
Yeah. So instantiation of S
Yes.
means which type S will take in the first call?
Integer.
It will take integer, right?
Yeah.
And T will take string.
String.
In the next call, S will take string. because it's a string type, and T will take integer.
Sir, here elements 1 and elements 2 in that show constructor are the actually argument, and their data.
Yeah, it's
type
just
is
a constructor,
array.
right? It's just a constructor.
Okay. No, elements 1 and elements 2 are actually arguments of type S and T.
Yeah, S and T will come to know in the runtime through the instantiation. So
Yeah.
since I pass a array 1, which is of integer type, the S will be instantiated, or it will take the type integer.
Okay.
And as I pass the second argument as a
String.
array 2, which is of string type, this T will take the string type.
Basically, it's like a dynamic dispatch.
The term I should not use a dynamic dispatch, because conceptually it's called as an instantiation. So which type you are sending over here?
But sir, that concept of methods, if I define more than one method by the same name, then that concept we call there as a dynamic dispatch, and here more or less we are doing the same thing. What is exactly
Not
the
exactly. Actually, if I pass over here integer, that means this this particular constructor having a version where it's basically having an integer with this element 1 and string with a element 2, like this. But actually the dynamic dispatcher, when a first and foremost thing about like a dynamic dispatcher, you should have a child class and parent class. That's the first thing. Now the decision, shall I call the function from or a method from a parent class or child class, the decision depends on the dynamic method dispatcher.
Yes.
Right? So here we don't have a parent child kind of concept at all. And we don't have to decide which function will be called. Rather, we are deciding which type the S will take, which type T will take.
Here more concentration is on type. In dynamic dispatch, actual concept.
It's a type parameter, right?
Yeah.
So S type is instantiated to an integer type.
Yes.
T type is instantiated to a string type. That's all.
Yes, sir. Yeah.
So for the first call, like first call in the sense, I want to say this one. For this first call, everything will happen where we'll assume this S is nothing but it's a integer, and we'll assume this T is nothing but a string. So wherever we are having S, we'll take it as a integer. Wherever we'll have a T, we'll take it as a string.
Yes.
But in real time, compiler do not replace it like this. It's basically again convert in a object type or some other type. That's called a erasure. So we'll come to know afterward. Like, it looks like this S becomes an integer and this T becomes a string type, but internally whenever compiler will replace, everything will become here object type. So that is the internal implementation by the compiler. We'll see afterwards. But whenever we are in the compile time, before compilation, whenever you are looking at it, you need to think it as an integer and it is as a string, and accordingly the checking will happen. So that's why if you instantiate it with an integer and if you pass something else, a double or a string, it gives you an error. This one. So we have constructor overloading here, right? This is a constructor with single parameter. This is a constructor with two parameters, but the data types are different. So you can pass it with a single parameter, we can pass it with a double parameter, but why these two are not happening? Anyone?
Because it is the int type and the character
Again, the
type.
primitive type, which do not work. But are you clear about why this 4 works?
Yes, because
it's It's a constructor overloading. This is a single parameter. This is a double parameter.
Yes.
We need to only check if the parameter types are accepted as a generic parameter type. Yes, they are accepted because they are integer and string, the reference types. Okay. Which one will go for? Okay, this one. This is your multiple thing. You're asking about the multiple, right? This ampersand to a multiple, but you need to make sure this is a class or abstract class followed by the interfaces.
Yeah. Can you
So,
explain this?
yeah. So it means to say the upper bound of T is number and runnable. Means T is something which will implement the runnable interface, and T is something which also inherits the number. Right? T is something which inherits the number and which implements the runnable.
So runnable is what actually?
Runnable is an interface. Runnable is the inbuilt interface in Java.
Okay, so if runnable is the interface, we write the implement runnable. But in the previous question, that X was also interface.
Yeah, that's what I'm saying. Always we use extends here. There is no concept of writing implements. So it may be a class or interface, does not matter. So we need to write it using ampersand.
Is it
Okay,
always true for the multi-threading, because this runnable is used in multi-threading, no?
No, it may not be inheriting the number, no, always. Yeah, threads are always runnable.
No, if I am doing for multi-threading, then only I can implement this, or it is possible to implement anytime, like runnable interface.
If you want to implement runnable, then you have to implement the run method also.
Yes,
so runnable basically having an abstract method, that is a run method.
yes.
So if you implement the run method, then you can do it. Like you can create a class. Suppose its class is as a say X, which extends number and implements runnable. So here basically you have to implement this public void run, which comes from runnable abstract. You need to must define this. So for this particular class, you can have this. Or you can customize, like you can create just an interface, like any interface, like interface X, and you can create a abstract class Y, and you can create a normal class Z. You can write extends extends Y and implements X. So in that case, this Z could be passed over here. So you can have a repository of Z. So this is allowed because it is implementing the Y, sorry, implementing the X and inheriting Y. So here you may, instead of this, write a Y, and here you may write a X. And you can test it. Yeah.
Yes, sir.
Achha, we won't go in a detail of it because it's discussed in week 6 basically. For the time being, just have the knowledge that this array list is a collection type. It's a predefined type in Java. So which comes as a generic version as well as a non-generic version, which comes in two flavor. It could have a generic version and a non-generic version. So if I write just a array list L, it's a non-generic version. So L dot add I can add a L dot add, I can add a number. So it's basically creates a non-homogeneous kinds of array or list, array list. And the generic version is basically type safe. So if you just say it's a string L, so it will, you can add only strings, right? That's the thing is. So here, if you look at, this is a predefined type, which is a collection type. So collection means a grouping of data. So we can put, so array kind of a grouping of data, right? So here array list, whenever I specify, it is for string. So I do an instantiation for the array list for a string. So I can pass only string data, right? I can pass only the string data, but adding function, calling the adding function, I'm casting the generic type to a non-generic type. It's a non-generic type. So once it becomes a non-generic type, I can add a boolean, I can add an integer, because as a generic type, it is type safe, means the data we can have inside our array list are of the same type, So as specified, it must be always string. But whenever I go for a non-generic type, it becomes a non-homogeneous kind of list. So you can add a boolean, integer, or any kind of thing. So once you want to print it, so since it is a reference type over here, it's a class, right? It's class. So whatever changes happen to this L, it will affect this, because this list I'm passing. So it's a pass by reference, because this is a class object, right? So that's why it prints this hello, right? It will print this hello, then this hola, this hey, then false, this 10. So a generic type converted into a non-generic type to add heterogeneous data into it, different data type. But this concept will be more clear in the next week. For the time being, just remember this array list is a predefined collection type in this particular package of Java. So which can have two versions, a generic version and a non-generic version. So generic version can be instantiated for a specific type. So it takes homogeneous data. Since it is instantiated to a string, we can add only strings. But here it's a non-generic type. So that's why I can use the data of any data type. Data of any data type. Is it okay for understanding for the time being?
Yes, sir.
But how the casting happens between a generic and non-generic type, we'll take up afterwards. How this handled by a array list. Which of the following classes are not predefined inside a Java? So it's a different kind of question. So class, object, thread, methods, all are predefined types. So thread, for defining a thread. Methods basically encapsulates a method of a given class. Class encapsulates a class. Basically, whenever you want to find out what is the class type of a given object, it returns basically the class type variable, and object is at the top of all the objects, all the data types, right, in Java. Okay. What about this?
So here get class is defined.
Yeah. Get class return the class or the type or runtime type of the object. It's basically the runtime type of the object.
But if I'm having comparing this like a parent with a child, so will it be equal because subtype covers the parent one.
It gives you
It
the
should be-
runtime type, not the compile time type. So it's basically depends on right now where you are pointing to.
So is it literally going to check definition like computer and laptop in this case?
Yeah, it's basically finds out in the runtime where it is pointing to or what object is referring to. It's basically the runtime type. So if you look at over here, the computer one is pointing to a computer type.
Yeah.
Computer 2 is referring to a laptop type. And laptop
Yeah, changing here the
is
reference.
pointing to computer 2. So it's basically pointing to this. So type of these two are same because they're pointing to the laptop object. So if you say get class, it should return a laptop. But here it is pointing to a computer object. So it returns a computer, right? So this will not match, right? So this returns a computer type. This returns a laptop type. So it will be printing both are not equal.
Yes, sir.
This is also similar. So vehicle 1 points to what? Object of a
Vehicle class.
vehicle class. Vehicle 2 points to a car class. Right? Although the static type of them is same. Right? But the dynamic type and the runtime where they're pointing to, that is different. So this is wrong. We'll get
But sir, in
this
earlier
again.
case, we written laptop equal to in bracket laptop. Then we change that reference, no?
See, this does not matter actually. So where you're pointing, does it matter like where it is casted?
So casting doesn't matter here.
No, really does not matter.
Okay.
So because if you're casting it, like it's basically a parent is pointing to a child, right?
Yeah.
So which is legal, even if you don't give this, does it create any problem?
That is what I was thinking in earlier problem, but I thought it is based on
No, if you look at this also, if you say a computer 2, right? Computer 2 of a type of
laptop initially.
Yeah, laptop. So laptop object can point to a laptop only, refer to a laptop. So for that we do not need the casting. I think probably if you remove this casting also it will work. You may check out. No, here casting is required because the problem is here the casting is required because the data type of the static type of computer becomes a computer 2 becomes a computer, right? So this is of computer type, static type, and this is of laptop type. Now compiler doesn't know actually where it is pointing. It sees the computer getting casted to a laptop. So computer is a parent type which is getting into the laptop type, which is a child type. That's why the explicit casting is required. See, we got laptop.
From lower to higher, casting is important.
Yeah, casting is important. So it's a computer, right? So whenever you want to convert a laptop to computer, then this casting is required.
Yes.
This is static type.
Mm.
But computer to laptop, it's not required. It is implicit. But that changes the static type of the reference. It doesn't change where you are pointing to, right? It doesn't change where you are pointing to. So that's a runtime event. So it basically means laptop will point to the same location where computer 2 is referring or pointing. So computer 2, where it is referring to a laptop object. Thus, laptop also referred to a laptop object.
Okay.
So if you see over here, it's basically also same thing. So here the vehicle 1 refers to a vehicle object. Vehicle 2 refers to a car object, which is obviously fine because it's in terms of dynamic method dispatcher, it is always allowed a parent can points to a child type object. So that's fine. So that's event doesn't require any casting also. So they are not equal, right? C1 will be a vehicle, C2 will be a car. Is it okay?
A little confusing. I will go through this again, sir.
Okay. Just one thing I'll tell you. AB, there are two classes, right? You are having an object of B, you're having an object of A. Correct? So
Yeah.
A type can refer, sorry. It's object of A, this is object of B. This is allowed. This is allowed. This is allowed. But this is not allowed. Up to
Yes.
this, okay?
Yes, sir.
This is what happens in the runtime. Why I say runtime? Because until and unless you run your program, your object won't be created. So you don't have the knowledge. It is pointing to a child object. It is pointing to a parent object. You don't know that. That information doesn't come to the compiler. Compiler cannot see where actually A is referring to, where B is referring to. Is it okay? So if I want to know what is the runtime type, so we can discover it only on the runtime. That cannot be discovered by the compiler, right?
Yes,
Is it
sir.
okay?
Yeah.
So compiler deals with the static type checking. What is that? If you have a type A and type B reference, so type A reference R1, R2. Now, if you want to cast R1 to R2, or if you want to cast R2 to R1, R2 to R1 casting is implicit. It is implicit because if you have A R1 equal to R2, it is implicit because you can refer to a child type. But this is explicit. This is explicit. This is means, sorry, it is B. This is means B R2 R1. Now R2 is a parent type which is getting casted to a child type, which is not legal normally. But you can do it at the compile time forcefully
By doing casting.
by the casting. Yeah, that's only the thing. But
So that
this
should be B or A. You written in bracket. It should be B.
it should be B.
It should be B. Yeah,
It
correct.
should be B. Yeah.
B, yeah.
It's not clean. No, it's a B.
Yeah, this one is clear. So
Casting have to be done or not, this depends by the compiler. Yeah, so compiler will enforce this, but this is decided by the dynamic dispatcher where I point to in the runtime. So dynamic dispatcher only makes sure where you are referring to. So if it finds you're referring to a vehicle, your runtime type is a vehicle. If it finds you're pointing to a car, your runtime type is a car. It does not matter through which you are referring, through which you are referring. So the simple way here, the vehicle one, what it refers, it refers a vehicle. Vehicle two, it's referred to a car. So these are not matching. If you look at over here, computer one points to a computer type object. Computer 2 points to a laptop type object. Laptop also referred to a object which is referred by computer 2. Now computer type referred to a laptop object. So that's why laptop also referred to a computer type object. So what is the runtime type of laptop? It's a laptop. Runtime type of computer 2, it's a laptop. Runtime type of computer one, that's a computer. So these two type matches, computer 2 and laptop, but computer 1 is doesn't match with the computer 2, computer 1 doesn't match with laptop.
Yes,
Yeah,
sir.
somebody one want to ask something.
Yes, sir. Excuse me, sir.
Yeah, please.
So one question. We have an instance of keyword also, right? For checking whether object belongs to a class or not. So I was just wondering whether it will give true for its parent classes also. Like
No,
can we say
it's not in the same way. Actually, instance of also look for the parent types also.
parent types also, no?
But
Okay,
it's basically
okay.
exactly give you where you're pointing to. It gives you the runtime type.
Runtime type. All right, that is what I was.
Yeah.
So we can say that laptop instance of computer like that.
No, problem of instance type, they cannot be compared straightforward way. It tells you it is of instance of a particular class or not, yes or no.
Okay.
But if you have two objects of two types, you cannot compare using the instance type like that.
All right, sir. Thank you.
For checking it, the get class is better option.
I mean, you are getting a Boolean value, right? So how can you compare a Boolean? Get class returns the object, that's how you can compare. So yeah, I think if you have gone through the that lecture, then it would be clear. Yes, sir.
Yeah, please. Okay, I don't know you have read this or not. So what it do, if you look at over here, we are having a human class which is extending the primitive man. So that means what are the public things are over here? Everything comes into human. Doesn't come like this how I'm drawing, but it's basically includes every methods of this implicitly. Now there is a way you can find out the information about a class, that's called a reflect. So you have to use import. It's a java.lang.reflect, no?
Yeah.
Yes, sir.
Yeah. Reflect star. You have to do this import. So this new object gives you an object of human class, right? So suppose we are having a human age equal to new human. So whenever you are doing get class, so this get class basically returns a class object which returns object C, which will store the information of the class of the object H. So that's why, since the class name of H is human, it stores the information about the human class. So if you remember in last two questions also you have used the get class. So get class object returns a class object. So class object encapsulate the information about the given objects class. So here the class of H. So class of H means human. So in this particular case, C encapsulate the information about the human class. So what information it encapsulates? If I say get constructor, it basically returns you the public constructor information inside this class. So how many constructor we have? We are having a constructor here, public constructor, right? See, the parent constructor directly doesn't get copied over here like this, although it's a public. So basically the methods will come. Yeah. So if I say get method, it basically put all the methods which are public inside the particular human class inside an array, which is a method type, which are of method type. So method type encapsulate information about a method, like what are the parameter types, what are the return types, what is the name of the method. Similarly, constructor type store the information like what are the parameters of the constructor, right? Then fields. So field type basically keeps the information about the instance variable, the public instance variable you are having in the class. So it's just we are keeping it inside an array because there may be many constructor inside my class. There may be many methods inside my class. There may be many instant variables in my class. So what are the public constructor we are having inside the human class that is stored in an array? What are the public methods are there inside the human class that stores in this array, methods array? What are the instance variable that stores into the fields array? Now, if you want to count like how many methods are there, how many constructors are there, how many fields are there, as it's just an array, you just can say methods.length, constructor.length, then fields.length. It's basically print this. So can you tell me what will be the output here? So if you give, let us count how many constructors are there inside the human class.
There is only one.
There is only one.
Yeah.
How many fields are there? So fields, see whatever fields are there inside the primitive man. So if it is public, that also will come into the human, right? But in this particular case, so do we have any instance variable inside human? Its own or inherited?
No.
No. Methods. So one, its own, two from the parent, right? So it looks like three, but is it really three? Is it really three?
So that parent class will also get inherited in the child, no?
Yeah, so I counted that, no? So your class having the method, one method, and two you are getting from the parent class. Two you are getting from the parent class. So it's basically three, right? So have we read like any class inherits the object class? Have we read this class object? We have read it, right? Hello.
Sir, please explain this. This is quite.
No. Up to this it's clear. No, the number of constructor is one,
Yeah.
field 0, and what the methods we can see it's 3. Up to this, is it okay?
Sir, yeah.
Everyone okay, right?
Yes, sir.
Yeah. Now I'm telling, in some lecture, sir has told this, and we have implemented something also. All the class in Java inherited from a class called as an object class.
Yes, sir.
Right?
Yes, sir.
Now, what are the methods inside object class?
Get class is one.
Object class having the methods like equals. Equals we have done, right?
Yes. Sir.
ToString. Can you remember? These are there in week 3, I feel.
Yes.
So what are the public methods are there inside the object class that also appears into your class also, no? So that will be there in human also, that will be there in the primitive also, right? Again, I repeat, we learned all the classes are Java by default inherits the object class because it is the top of the hierarchy. Is it correct? Is it correct?
Yeah.
So if you have any public methods inside the object class, that will appear inside your class also. Is it correct?
Yeah.
So what are the methods we learn which are there in the object class, like equals, then toString? Those classes also must be there in my class.
Yes.
So those has to be there. So now the question is, how do you find out what are there inside the object class? Is there any way? So give me a minute. See what it is giving, Java P. Then I have given the object class. Object class is a predefined class which belongs to java.lang.string. So it basically shows you all the methods inside this. So if you want to learn about any predefined class, what are the methods are there, you can basically use this Java P. So you can do java.lang.string class. What are predefined inside the string class? You can see these are all the methods are there inside the string class. So if you want to see what is there in the object class, these are there in the object class. So these many public methods, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these all will be there inside your human class as well as primitive man class. So that's why whenever it will print your output, it shows one's constructor, one's field, 9 plus 3. That's 12 methods. Anyone having doubt about this 9 plus 3?
But sir, here we shall know na, that 9 are there. So we need to check and then we can answer. If this comes in
Yeah,
exam.
that's why it is in the activity question.
Okay, fine, sir. Yes, yes. Got it.
So you have to have the knowledge, because it's not only your class. You're by default always inheriting the object class. So if you say human, human not only inherit the primitive class, it is always inheriting the primitive. So actually, if you look at top of everything, the object class is always there. So your primitive man as well as the human, both inherits the object. Fine. So that's why whenever you're counting the public methods of the human, it is not only the public method what is declared inside the human, it is from its parent class, not the constructor. If it is from the parent class, as well as the default superclass, that is the object class. And this is just for your knowledge. How do you find out if you want to test it? You can use Java P. Then whatever the package name, you can find out what will be the things. Right. See, runnable class interface, what you have. Somebody was asking, right? Runnable interface. It's just an interface. What is the definition of interface? It's having a public abstract run. So if you just implement this run method, you're runnable. Okay. Let us go back. Okay, please do this. So if you want to get public methods, then it is get methods. So if you want to get the methods exclusive to the class, right? Let us do the public first. Public instance variable, get field, public constructor, get constructor. Right. Now declared constructor, you can understand it's basically So it's basically, it says like it could be non-public also, right? So like that, it's the name says the thing. I think you can understand this. I'm not going in detail. This is about the wrapper class. So you are having byte for byte, short for short, int for integer, long for, there is no longer, it's long. It's basically wrong. It's not there in the output actually. This is float for float, double for double, char for character, it's wrong. And boolean for boolean. So that's why you can see two are missing. That's a D is not there, and a G is not there,
So
which are wrong.
what is the wrapper code long?
Long is long, capital L long. It's not longer. This longer is incorrect, right?
Yes.
Yeah, this one. Please go through once, then we'll discuss. See, this is a bit difficult question. There is a concept called as a closure. Right. So after the compilation happens, the compiler basically replaces this generic type with the upper bound, with the upper bound. Now, if the bound is not specified for T1 and T2, what will be the upper bound?
It will be object.
It will be object. So object, it becomes object. So after compiler do the replacement of this with the object, which calls a erasure, which calls a eraser, not closure, I'm saying closure, which calls a eraser. So basically this becomes a ambiguous function. It's not a overloading. It's not overloading, because after the compilation happens, the compiler try to recognize the types. It basically replaces this with upper bound. So upper bound for any unbounded type is an object. So after the erasure, that's the replacement will happen by the compiler. Inside your code will have this T1 and T2 both replaced by the object. This string and integer, this all instantiation are checked by the at the compile time. This instantiation, like passing a integer for a integer, character for a character, that happens everything on a checking on a compile time. But once compiler replaces the generic type parameters, which calls a eraser, it basically replaces it with the upper bound. So for a unbounded type, these are objects. So basically these two functions becomes a non-overloadable functions. These are conflicting functions because both will be replaced by object. So for this, we'll get a compiler error. So if you have read this, it's easy to understand, but without reading, it's very difficult for me to make you understand at this moment. But remember, only the thing is a generic type, after the compile time type checking, like for an integer, you're passing an integer, for a string, you're passing a string, that kind of thing. It replaces all the type parameters with the upper bound of that particular type. If it is an unbounded type, then it will be replaced by an object. If it is a bounded type, means extend something, then it specifies the upper bound. So in case if you have T1 extends number, then here it won't be object, it rather will become a number. So in that case, see, these are not conflicting. But since both are unbounded type, both will be replaced by object. So that's why it becomes a conflicting function, because after the eraser, both becomes the same kind of function, or the declaration, the signature of the function becomes exactly same. So that's why it gives a compiler time error, because T1 and T2 will have the same closure. Sorry, eraser. I'm telling the same mistake. So shall we move to the next question? I think if we discuss the next question, it will be much clearer. Is it okay?
The next question is with extends, no, sir?
Yeah, yeah.
Yeah, I think we can do.
So can you tell me here what will be the erasers? T1 will be replaced by what? T1 is a unbounded type, right? Hello? Hello?
Yeah,
Not audible?
Yeah, yeah.
you're very much audible.
Yeah, it is difficult. I mean, yeah, once they go through all the lectures.
Yeah, I think I may
Give me a minute.
skip this for the time being.
May I answer this one?
Yeah, yeah, please.
So yeah, since T1 is an unbounded type, so it will be replaced by object, because that is
Object.
the upper bound, right? And then
Yeah.
since T2 is extending number, so the upper bound for that T2 will be number itself.
Yeah,
Therefore,
yeah.
it will be replaced by
The
numbers.
concept is like,
Yeah.
if we replace the T1 with an object, it will accept anything with which is an object or child type an object. Child
Right.
type object is everything, so it will accept everything. But the eraser of T2 is a number, because it extends number, so it will accept number type or any child type of a number. That's the idea is. So if you make it object over here, it's basically accept anything, right? So it's basically accept like a generic type only. So that's the idea is. So that's why in this case, the first is a string. So string will be accepted by a object. The second is an integer, which will be accepted by a number. So if I'm passing it as a string and a number, so T1 will be instantiated with a string. This will be instantiated with a integer. Then I'm calling s.push, which is the hello. So it's basically call this one, because no way it is a child type of a number, or it's a number, right? So there is no confusion like which one has to be, which push has to be called. But in case of this, if I have s.push, then 10, then what will happen? Which one will be called?
T2.
Why not T1? Because
The second one
10 is
number.
an integer that inherits number also, object also, right?
Okay.
So it again becomes ambiguous call. Right? It will give a compiler error.
Okay.
Because it matches with both the things, no? Object also, number also. But if it is a hello, it is specifically matches with the object, doesn't matches with number. So like this, you need to understand which call will be successful, which call cannot be success. But overloading is correct, right? Because this is a different data type. It's a number type. This is object type. You can go through once at your, like afterwards, we can discuss it again on the next day. So I'm just going for the next. Yeah, this one.
Sir, can I try to answer this one?
Yeah, I'm asking you only.
Yeah, sir. The thing is that here the clauses are different. One will be resolved to object, and other will be resolved to number.
Yeah, first one is
But
object.
Yeah,
The second one is number.
number. But the problem occurs is that we pass number to both of them.
We pass a double.
Oh yeah, yes, yes, double.
Now question is, it matches this or this? It matches both, right?
Both, yeah.
A double is a number, a double is an object. So basically it becomes ambiguous call, right?
Yes, sir. Sir, just one question. How will the like this is a compile time error, no? So during compilation itself, like will this actually flag it when the example that number is created, or will it flag it when that end push line is reached? Which line will the compiler error be in?
No, this will be resolved by the compiler only. Compiler do a erasure of the type, like it remove this, replace it with an object, then it remove it, put it with a number, none, try to find out if you call end dot push, to which it will be binded for this method or this method. So it cannot be resolved, right? So then it raised the error. So it will be raised by the compiler itself.
Okay, so during while reaching the end dot push, it will raise the compiler.
Yeah, first the compiler will check out, do you pass a number for a number, like these are matching or not. So that's basically for the type safety. If you say a double passing an integer, then it's not permitted. That's for the type safety. It will check the exact type what you are giving, that's checking or not. Then it do the erasure. It find out actually which type will take internally. Then try to bind the methods.
Okay.
Yeah.
Yes, sir. So
Yeah.
exactly. So two situations. This kind of situation also can arise if both the types are, I mean, like extending from the same super type. Like for example, T1 extends
Yeah, it
number.
can happen, right?
Yeah. So same sort of situation.
Yeah. So if we have X
extending the same super
extends
type, in that case,
Y and Z extends Y, right? Y, and this is some class X, right? And in the definition, I can have a void get X some value V, and I can have a void get, then it's a Z V. So it's look like they are different methods because they are taking different data type. But what is the eraser will do? What is the upper bound of X? That's the Y. So eraser will replace actually this with a Y, and Z also replaced by the Y. So if I have a call like this, then it will be an ambiguous call, right? It becomes an ambiguous call because both are becoming Y up eraser box. But you need to read it properly. It's a bit difficult concept. Yeah, I can understand just 1 day or 1.5 day you got, but we can again discuss it, right? Yeah, this one.
I think the first like the first if will get the get class will be equal because it will be both resolved to example enclosed object in both the cases.
Do you have more questions? Shall we discuss this one next day? I'm not discussing now, right now. Yeah, I'm keeping it for the next day because until you are reading it, Like there is no point to discuss. This is more difficult one. Which are the wrapper classes extending the number? So it's byte, integer. This boolean and character doesn't inherit the number because these are the number type. Byte, integer, long, double, float. These are all extend number. These are the definition. What is what, right? So erasure. Basically, these are basically the runtime type of the variable. So it will be promoted to the upper bound as we discussed, right? It will be promoted to object or to the upper bound, each of the parameter type in case of generic. There is a concept of auto boxing. So implicit conversion between the primitive type and the wrapper types. Primitive types and wrapper types. Wrapper classes. These are the classes representing the primitive type, right? Which are compatible with the object hierarchy. Like you are having a number, then number is inherited by an integer, by a float, by a double. So it becomes a class hierarchy whenever we make it as a wrapper. And finally, we have a generic type or generic class. It's a single class interface or method that can be used with different data types. It's basically a generic type. So it's a straightforward kind of thing, but I think the eraser portion I need to discuss again next day, right? So I'll suggest everyone to read this, and the wildcard portion, read it properly. I didn't touch the wildcard at all because it's very difficult concept in that way. So please go through that, then we'll discuss. So anyone tried with the practice questions, PQ?
Programming.
No, I'm PQ, like a practice question I'm
Oh,
asking,
acha.
week 5. I don't think
Yes, sir.
anybody has done. Yeah, you have done, right?
Yes, sir. I just attempted. Okay.
So do you have any doubt, like anyone? Otherwise, we'll go for the programming or something else. I think, Bhaskar, we can go for a bit of programming now. We can stop this. Hello?
Yes, sir. We can.
Yeah. Bhaskar, would you like to explain that one program is left, I feel? You're not audible, I think, Bhaskar. Yeah.
Okay, just a second.
Yeah. Okay.
Yeah, so before going to the problem description, I mean, what was the number? Let me just open that. Just a second. So that one question was there na, regarding election, voter, one programming question. So has anyone tried that or you did not get the time? I mean, in week 4, one programming question was there na, regarding elections, EVM and voter.
For that one, we had to make 2 unique singleton classes for.
Yeah.
Yes, sir. I have done, but I'm not sure whether it's correct or not. I just like manipulated it enough so that the outputs are correct.
Okay, so can you tell me what you have done? I mean, what was your approach? Or okay, let me just.
Yes, sir. Just let me just open that one. I think it was practice 2. Yeah. Sir, in the first one, in both, I left the private voter that constructor untouched, and then the public static voter get voter. I implemented a single class that that is similar to a previous live session where if a new voter that the static new voter is null, then we create and return a new class, new voter. Otherwise, we return null. And the same for EVM also.
Okay.
And then the same singleton behavior. And the first voter, I left it untouched. There is no, I did not change anything in that one. And the call new voter, I put a logic that new voter has to be changed to null, the static variable, and then if then I do that particular check if current voter is greater than total number of voter, I just simply return it. That's just the that just signifies that it has ended, the voting session has ended. And then after that if condition, I call a new voter, and a new voter, the private class, and then I call an EVM, using the get EVM method, and next and all is the one we had to leave untouched, ignore the following 6 lines like that. And then at the end of that one, EVM dot start voting, I gave just this one line. And for the EVM also, it's almost the same, except that I increase the EVM count inside the private EVM, and then create a current voter is equal to V also. And then in the new EVM, so the get EVM, the same logic as the voter, that if it already exists, return null. If it is null, that new EVM is null, then you can return the object. And then in the start voting, I have put the print statements, that is the voting under progress on EVM number and the voting completed for voter, this one, those two print. And then after that, I have set the new EVM, the static voter variable to null, and then the current voter in that one. And then I call current voter dot call new voter function, and that's it.
That's exactly the way how it has to be done. So I think, I mean, I was just reading my code, and whatever you are saying, that was just line by line saved. Okay. So that is exactly the way you have to do it. Great, excellent work. See, the idea is, does it look similar? Okay, sorry. So I did not notice your name. Can you tell your name once?
Rahul, sir.
Rahul. Okay, great. Yeah. So Rahul, it looks similar, right? Something like the same thing you did.
Yes, sir. Almost. Yeah.
Same thing. Yeah. So see, the idea of this code is, let me just open the problem statement once. See, the important points over here is there would be a voter class and there is an EVM class. Now, very important thing is there should be a bijective mapping. Okay, so bijective mapping means a mapping which is a unique mapping. Did you all learn relations in your maths classes? I mean, maths 1, maths 2, bijection, surjection, these things, are you aware of?
Yes, sir. Maths 1, I think.
I mean, in the curriculum it was there, na?
In maths 1, sir.
Okay. Then I will just use that term only. So the mapping should be a bijective mapping. That is, it is a 1-1 as well as onto. It is a, I mean, injectivity and surjectivity both should be there. Which actually means that you will be able to map a unique voter to a unique EVM and vice versa. So this exact pattern, while you make, and also another important feature would be there, that once a voting process for a single voter has started, right? Voting process means the EVM allocation. So once a voter gets a EVM, right, no other voter can come in between and demand an EVM. So this is like a locking, right? Once a voter gets an EVM, that is locked. You cannot use that. Okay. So how to implement such a feature? How to make such a thing that once I get one voter, I will not allow any other voter, and I will also not allow any other voter to take any other EVM. So once the mapping is done, it is done. Until and unless it is finished, then no voter or no EVM can be created. So this kind of locking features you would need in real life programs a lot of time. So you can do that by using this calling back in a singleton class. If you essentially see this this code, right? So if we eliminate all the abstract things like voter, EVM, and all other variables and all, this is basically a simple callback which you all learned in this week, correct? Simple calling back between two classes. The only difference over here is it is using singleton pattern. So that will help you attain this feature, that once a particular lock, I would say, is generated, once a mapping is done, until and unless that work is finished, you will not allow any other thing to come in between. Now, you may feel it is not relevant now because now we are executing in a serial fashion, right? So let's say if I execute this code, see the output. Okay, I will not walk you through the code, just give you the skeleton structure of it. So I would request you, you should try it. Not even if you do not get time now, you please try it later, right? So yeah, try it. If you can see it, if you can check it, I mean, even if you seeing, if you try writing it, typing it out on your ID, that is also fine. But just go through it. Okay. Okay, so where is that console? Just a second. Okay, fine. Anyways, I'm doing it over here. Okay, so let's take, let's say we enter 3, right? So we have 3 voters and 3. If you go to the main method, if you see the given inputs, right? What are the possible input in the test cases? If you go over there, you can see that we are taking the total number of voters, right? So that was also given in the test cases. You can check that. We are taking the simple total number of voters. So the total number of voters, I'm putting 3. See, the thing is this mapping na, that EVM number 1 for voter number 1, EVM number 2 for voter number of 2. So this mapping, that 1-to-1 mapping, it would make much more sense when you do this code in a multi-threaded environment. If you implement the code in this manner, na, and yeah, so then what you can achieve is this mapping would be unique. Otherwise, in a multi-threaded environment, what can happen is EVM number 1 can get allocated to voter number 2. Okay, simple code. This code only in a multi-threaded environment would work differently. So in order to keep that thing same, I mean, yeah. So in order to keep that thing same, you have to make this to singleton and do the code like this. Some changes would be there, but yeah, main thing would remain same. So the main idea is this thing. In many types of coding, you would need to use this locking implementation where you need a one-on-one mapping where each object of one class would be mapped to a unique and distinct object of another class. And yeah, it would occur in a serialized fashion so that there is no interruption of another object which may, yeah, interruption of another object in the process of the other object, right? So this kind of thing may occur. So basically, this is a callback function using 2 singleton classes. And I would just briefly define how it is working. Although your friend, I mean, Rahul, right? Yeah, Rahul told the whole thing. That is exactly how it is. So basically, singleton design, we have discussed that you define a static method which you can access from the main, right? And the constructor would be private. Right? So here we are just keeping a static variable to keep a count so that we get this output. You see this output now. 1, 1, 2, 2. These 1, 2 are basically, these values are kept in the voter count, this variable. Fine. Okay. So after that, it's a normal singleton pattern. The only difference is over here, which is a basically callback method. Okay. So simple thing. I mean, if you just remove the comments and this whole code, it would be smaller. So mainly I'm checking that whenever a new voter has come, right? Because you will, after calling back, so basically here we call the new voter, So when the new voter comes, the old voter must be made null, right? And how we are getting the old voter? As you see that when I come to this class, EVM class, right? So here we do this thing, current.call new voter, right? So once we go to the call new voter, see what happens is, once we go to the call new voter, we should make the current voter as null. That's why we are making it null, and then we are printing voting completed for the current voter. As Rahul also said the same thing. Then we are just checking whether all the voters has completed voting or not. If not, then we are calling the new voter using get voter method, which is basically the static method over here. Okay, and it would actually call the constructor internally, as you see here, the private constructor. Right? And once I get the object, then I allocate a EVM to that particular voter using get EVM. Now this statement, line number 37 of the code is a bijective mapping. It's a one-on-one mapping, and once it is mapped, it will no other object or no other EVM, no other voter object or EVM object can take the one which is mapped, right? So once that is done, then this is just a code to check whether your singleton pattern is actually implemented or not. It just tries to create an object and checks whether it returns an exception or not. So ideally, if you have implemented singleton pattern, then when you try to create an object, when you already have an object, so get voter, you got one object, right? So ideally it should return null. Therefore you will get a kind of error which we call exception. It's called null pointer. So basically this 6 line only checks that whether your singleton pattern is implemented or not. So you can ignore that in your submission. And then finally, once we get the voter and the EVM allocated, here the EVM is allocated to the new voter, right? In this line 937. So once it is allocated, then we are simply the new EVM that we got, new machine, we are using that to do the start voting. Okay. So that is the basic idea. And also once you come back to this method, then the start voting will have whatever voting under process or whatever work you need to do, you will do. In real life scenario, you will do some proper work over here in the function, right? In this function over here. So it's just a println statement, but real life you will do all the necessary work after gaining the lock over here. And then you will again, after the work is finished, you will call back to the parent method. And then you come over here again, and that's why I set the previous voter to null. Okay, and then the new voter is again called. So this process continues until all the voters are finished. Okay. It's a little bit involved, and if you, rather than explaining, the idea is important, but once you get the idea, you have to think of it on your own. Otherwise, it would not be clear by explanation. So as soon as you start asking doubt about it, then I think we can be in a more comfortable position to explain it. But walking you through the whole concept, it would not be fruitful as long as, until you start doing the code on your own, think it on your own. Okay, so yeah, but the idea what Rahul said, that is exactly how the code should work and how it works actually. So yeah, fine. But I request you all to try this. If you get time later also, please try this, because this is a very important pattern of coding that you would require in your development days when you work in an organization or whatever. So you would need this kind of pattern. Okay. Yeah, so that was it. I think we are done for today, right? Arup sir, do we have anything else?
No, nothing.
I guess Aru?
No, nothing today. So if you people have anything, like we can.
Yeah.
No, I think, right? So shall we close the session today?
Yeah, Aru.
Okay. Then thank you all. Okay.
Thanks everyone. Bye.
Thank you.
Thank you. Thank you.
Yes.
রে সর্বনাশ করেছে। আমারও হচ্ছে। রে